So we're going to talk about some terminology associated with random experiments. So the random experiment question, any experiment where you can't predict the outcomes is considered a random experiment. Some things feel more random than others, but life is pretty much random. That's weird. So the terminology associated with life, I suppose you could say that. The sample space is a list of all possible outcomes. So sometimes that list is finite, only has a finite number of things that can happen, but sometimes that list corresponds to an interval in the real line. That can happen depending on your experiment. So if your random experiment is having a newborn, and then what you're going to measure from that newborn is the weight of the newborn, then if you list all the possible outcomes, you could say, well, maybe between 2 pounds and 10 pounds, any number might be possible, and that would be your sample space. So a list of all possible outcomes. An event is a collection of outcomes should say maybe a subset of the sample space, but that sounds a little too fancy. It's a set. It's a subset of the sample space. And in fact, sometimes we'll give these things letters. You might see the sample space could be called S, like that, and events are like A, B, C, D, E. So that's notation. If we need to just describe an event, say here's an event. Just pick an event. I want to just have a name for an event. I might call it A, B, C, D. And if I say there's an experiment, the sample space, we'll just call it S. You'll see how that works in a minute. Well, a couple minutes, I suppose. And then the probability of an event. So the probability of an event. So I wanted to give it a name, but I guess we can get away without doing it. This is the long-term relative frequency so the long-term means many experiments. Many experiments. Or many repetitions of the experiment. And relative frequency means the fraction, number of experiments in the denominator, number of times we see outcomes in the event happen. So we say probability is trying to describe the long run value. So probability describes the long run value of the number of times outcomes in the event happen divided by the number of experiments. Okay. And a probability model is a way of assigning probabilities to events. We can test how realistic the probability model is by doing experiments with specific events and seeing if the answer that it seems to provide matches our experience when we compute this fraction. So just to verify it. So here we go with dice as an example. Well, 2 dice as an example, I guess. Our experiment is going to be roll 2 dice and sum the pips on the up-facing side. So the pips are those dots on the sides of dice. So if you have a die, say, that's well, I don't know what's on the other faces on this one. It might look like this. then the up-facing side would have a 2 on it. Maybe you have another die sitting next to it that you just finished rolling, challenging my artistic ability. That, so the up-facing sides, the sum would be 8. 6 plus 2. So if you do that with dice, the faces of the dice are 1 through 6. And so if you add two numbers together, between 1 through 6 together, they're 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So the smallest number you can get is a 1, 1, which is a 2. The biggest you can get is a 6, 6, which is 12. And you can get every number in between 3, 4, 5 by using numbers between 1 and 6 and adding them together. So if our experiment is rolling 2 dice and counting the number of pips showing on the 2 dice, then the result of the experiment that we're interested in are these numbers 2 through 12. Now your events can be pretty complicated. The sample space can be simple, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's an event that's a more complicated event. So we could call the events where they involve a single outcome simple events. And events that involve more than one outcome, we can call them compound events. So here's a compound event. You are happy if you see 10, 11, or 12. So if you're playing craps, something like that, there's certain combination of values that will help you to win, and certain combinations of values will help you to lose. And so events involve combinations of outcomes, not a single outcome. So we're just going to use this event, 10, 11, 12. We'll say the event happened if I roll 10, 11, or a 12. We could say the event happens if I roll something 10 or larger. We can say the event happens if I don't roll 1 through 9, 2 through 9. But 10, 11, 12 is what I'm looking for. So we define an event here in a collection of outcomes, 10, 11, 12. Those 3 outcomes are part of the event. The probability of this event is the number, the fraction, number of times you see 10, 11, 12, divided by the number of rolls, gets close to as the number of rolls increases. So more and more rolls. That fraction of the time you see 10, 11, 12 divided by the number of rolls should get close to some number. And then the probability model question that we have there, we're just going to do that later. We can't do it now. There's a way to assign probabilities, but we're more interested in the experiment in a more basic way at the moment. And then our question we're trying to answer now, based for that experiment and that sample space and that event and that probability question. Of 11 outcomes, we chose 3. Is the probability of 10, 11, 12 3 divided by 11? Sometimes that happens. So if those outcomes were equally likely, then you might say, since there's 11 outcomes and I'm only choosing 3 of them and they all happen with equal frequency, then the chance of seeing those 3 out of the 11 should be 3 11ths, and you would be right. But I'm not sure about how equally likely these possible outcomes are for dice. And it's conceivable that 10, 11, 12 occupy 3 11ths of the long-term fraction. It could be 3 11ths, even if they're not equally likely, just because something unusual happened. And so we're going to take a look at some data and some ways of analyzing the dice experiment to answer the question, is the chance of rolling 10, 11, 12 something like 3 11ths? And we'll find that out in a minute.